In modern medicine, turning 65 often acts as an arbitrary line in the sand. A patient crosses that threshold and is suddenly stamped as high risk, sometimes disqualified from procedures that could extend their life. Our medical system is built to fight conditions like heart attacks, strokes, and dementia as entirely separate, isolated problems. This approach ignores a critical underlying factor. Aging itself is the root cause driving all of them. If we treat systemic aging as the source, the math changes. Intervening at the biological level of aging offers a way to shift the trajectory of multiple degenerative conditions all at once. To actually manage systemic aging, we have to move beyond the traditional one disease, one treatment model. We need a method to rewrite the body's global biological environment. The first proof that this environment could be rewritten came in the early 20th century through experiments in heterochronic parabiosis, a procedure where the circulatory systems of old and young subjects were surgically joined. The biological results were hard to ignore. The older subjects experienced accelerated tissue healing and physically behaved like much younger animals. Rejuvenation was biologically possible. These experiments suggest that aging functions as an active biological program, driven by specific chemical signals circulating in the bloodstream. Translating this to humans presents obvious logistical and ethical walls. You cannot surgically connect people, and traditional therapeutic plasma exchanges require large-volume hospital-based apheresis, central vascular lines, and a heavy reliance on foreign biological materials. Curious, this leaves medical science with a very specific problem to solve. We need a way to safely simulate the rejuvenating effects of young blood without actually requiring a young donor. The answer lies in how cells communicate. The rejuvenation seen in parabiosis doesn't come from the physical transfer of young cells, but from soluble factors, the microscopic signaling molecules those cells secrete into the plasma. Over decades, a patient's plasma environment degrades. It becomes saturated with harmful inhibitory chemical signals, while the body's natural regenerative proteins steadily drop off. We don't actually need to replace an old circulatory system with a new one. Instead, we can extract a portion of the patient's existing plasma and reprogram it outside the body. Because these secretones dictate how our organs repair themselves, rejuvenation becomes a task of managing these instructions. By deleting inhibitory signals and rewriting regenerative ones, we are effectively editing the body's global signaling environment. To see how this works, we can look at this diagram of the PX-150 protocol. It starts with a standard 250 milliliter blood draw, isolating 150 milliliters of plasma. This fraction is heavily diluted, dropping the concentration of harmful signals. But washing away inhibitory signals also waters down natural repair proteins. To rebuild specific repair signals, selected stem and progenitor cells are introduced into this diluted plasma in a controlled laboratory, giving them time to adapt. Once adapted, these cells enter an active secretory phase. They begin actively pumping high concentrations of regenerative signaling molecules back into the diluted fluid. This cellular action physically replaces the beneficial proteins that were diluted away, customizing the fluid with the patient's own personalized biological repair markers. This newly optimized plasma is then stabilized using human serum albumin. It is serially diluted one more time to reach a precise therapeutic volume, typically around 450 to 1300 milliliters. Through this multi-step engineering process, a single cup of autologous blood is transformed into a standardized, scalable regenerative fluid, requiring zero exposure to foreign biological materials. Unlike traditional therapeutic plasma exchange, this small-volume protocol requires no large-volume apheresis machines, no central vascular access, and no overnight hospital stay. The finished fluid, now an upgraded, highly customized biological signal, is safely returned to the patient circulation through a standard IV. Once returned to the circulation, this customized fluid broadcasts a systemic command. It coordinates a regenerative response that instructs tissues across the entire body to begin repairing themselves, successfully simulating the chemical benefits of parabiosis from the inside out. By targeting the blood directly, we can move away from treating isolated symptoms and begin managing the body's systemic homeostasis. This protocol is designed to integrate into a continuous cycle of outpatient care. It utilizes AI-driven outcome tracking to measure true biological progress and guide the exact timing of future retreatments. With every patient treated, the platform continuously learns, gathering data to build a global prospective clinical registry for regenerative medicine. The future of treating age-related disease doesn't require searching for external cures. It comes down to mastering the chemistry required to correctly instruct the biology we already have.